Hey everyone, we're going to take a look at 2D velocity maps with TP. This is a technique that we used on some shows to drive particles in a certain direction just based on a texture map. In this case we're going to use a piece of geo and the particles look up the color on the surface, then they use that to kind of control which direction they go. Now there's some nuances that we'll have to be careful of, like when they get pinched. And so you just have to kind of figure out which color is going to direct the particles in a certain direction. So let's take a look at how we do this. Here in a fresh scene, we're going to start with the color wheel. The color wheel, red, it goes to the far right and rolls around clockwise or counterclockwise, comes back into red. And what we're going to do is say, well, first we're going to birth, a bunch of particles. It's real simple, birth on a surface in this case. We've got to switch from surface or volume. This Boolean is true. It hits an egg timer with a single check, and so it only fires off once. That gives us a burst. You don't really need that in this case. You could just do that. Just part of our black box. So what we're going to do is say all particles are going to look up the surface of an object. Just going to be our plane, and we want to get the nearest surface position. So we're going to use geom particle, and we're going to get some point data from that. So let's get a geom point. Say, yep, closest point by surface is this. And what this is going to tell us is it's going to read out a color for us. So we're going to break that color down into components, because what we want to do is we want to use the hue to drive which direction. We want red to go to the right. We want this lime to go straight up. We want this, whatever you're going to call that, cyan to go directly left, and purple to go down. And anything in between blends in between. So here's one way. Of course, there's many ways to build it in TP. Go ahead and we're going to, it's actually going to treat these colors almost in radians, but it goes from 0, comes around to roughly 3 on this side, and comes back to 5.999. So what we're going to do is read the hue into a value to value, where the minimum hue is going to be 0, the maximum hue is going to be 5.99, and our output here is going to be 0 to 360. What we're going to do then is we're going to convert these. Now, what we're going to end up doing is we're going to use a cosine and a sine. But before we can really do that, we have to remember that these functions are expecting radians. So let's drop a degree to radian out here. Connect that to these two, and kind of assemble that into the x component, y component. And for now, we're going to start with a simple velocity assignment, where this is going to be the direction. Let's see what happens. Okay, so we see these colors moving away from the origin. So this color drives it this way, this color drives it this way, etc. So everything's kind of working in the color space and color direction that we are after. Now, that's all good and fine, but we want to be able to paint and control these so we can direct them. So I've got another map I'm going to drop on here, and I'm going to add more particles. Let's do 500, and now what we'll notice is we get this clumping, right? You get this real tight formations in between where colors are. And sure, it's neat, but we don't necessarily want them doing this. And it's kind of cool that they come down here into this radial center. That's partly because of our source image. We based it off of this. So we have some of those colors just rotated. Actually, before we do this, let's show you what this looks like. If we take this object and rotate it about 90 degrees, our particles start running clockwise. That's because when they hit red, it knows that it wants to go to the right, and when it hits cyan, it knows it wants to go left, and everything in between just kind of blends and points. So, kind of fun if we run it this way. What'll happen is they all basically congregate toward the middle because it's going the opposite direction. The red points this way, this points this way, so it's basically come to the middle. Let's zero this back out. Let's get our other image on there. Okay, so let's take a look at first a simple case of how we can examine these colors and figure out how to paint this map in the way that we want. The way we're going to do that, I come into Photoshop. We've got this color wheel set up already, and remember, these are set up so that this color red aims this direction. This color aims this, and so this is already pre-set up for us. So if we want to control these, we can say, hey, I want stuff to go, when stuff gets on this far left side of the image, you know, I want it to go to the right. And when it gets to the right side, well, I want it to go to the left. Right? So let's go ahead, we'll save that. Jump back into Max. There's our map. Okay. And so here's the problem, right? You can see that it hits this middle color band and they all run down the line. Well, the way we're going to fix that is we're not going to have them use the velocity direction right away. We're going to give them a little bit of a delay on that. So what we end up doing, actually we can keep that. What we're going to end up doing is using a memory. And remember, a memory is just a way to store a variable per particle per sample, or any time that the on is turned on if you use that. Now, I want this memory to be separated from the actual connections of the particle, because in case we decide to move it or make some big changes or anything. Put that up there. And we're going to add a variable to this memory, and we'll call it direction. Just drop it in. Go to this other memory, which is this guy here, and access the variable that's on that mem. Just drop it in here. Okay, so we can say take that. Great. And now what we're going to do is, well, let's just duplicate that memory. Use this as the output. And what I want to do is I want to basically add kind of a lazy steering to this so that it doesn't happen right away, but it takes time for it to change direction. And the way we're going to do that is with the standard alignment. And alignment has a laziness factor. And for beginning, we'll just go ahead and set this to 20. This needs to be user defined because we're going to control the direction based on the direction of alignment based on the direction that we receive from the color map. Then we're going to take that direction, we're going to feed that into the velocity. Okay, so now you see that they cross the line and then they end up kind of sweeping back, and so there's this very lazy kind of behavior to it. And actually some of them are popping off, I think, because I think that they go, yeah, so they're running up like this. Let's take this Z out of the equation. Or maybe part of our alignment is also messing with that. Well, actually what we need to do is we need to zero out, I think, this direction so that it's not having any Z component at all. So to do that, we take the direction into a 0.3. We use only the X and the Y, and then we're going to go ahead and assign a float to Z, set it to 0 explicitly. So there should be no Z direction in there. Okay, all better there. So yeah, they go flying back and forth. You see this guy kind of escaped. This must be he's following the nearest surface point, Apache still reads. Okay, so they're kind of doing what we want. That's great. But now let's go ahead and make something a teeny bit more complex. And let's look at, okay, let's say we want them to kind of run around in a square pattern. Well, I'm going to take some green because I want them to go up. And I want them to go up when they get to this bottom corner. When they get to the upper left corner, I want them to go down. Okay, and then we've got red still. And of course our lovely teal. Okay, I'll save that. And okay, so I think our direction change is a little too slow. Let's try 10. Maybe I got the color wrong. Actually, let's aim up a little bit to the left with that green. The teal, we can come down a little bit blue from the top. Maybe we'll make some of that a little bit purple. Kind of stem them in this way a little bit. A little bit of the red. Keep out of there. Oops, wrong max there. Okay, so they're mostly kind of behaving. We see this green is kind of ending up in here. So we get kind of an interesting thing, and then they kind of formulate and end up kind of following this pattern, right? So let's add some variation to their laziness, because we don't want them all to be the same. Let's go ahead and pick a random per animation with a laziness between, I would say, 7 and 25. And that is going to feed into our laziness parameter. I'll go ahead and check it out now. So we're going to get more randomization in their direction change. So it should formulate that pattern less. We can see that they're spread out already. So yeah, you end up just using this map as a guide, and you think, well, if I want the particle to go up to the left, I'll just use that color. And I could put some of that in here. Let's say I really want them to go down, or down to the left. Put some of that right there. You want them to go up in here. We'll just grab a little of that. Save. So use this as the direction as the direction indication. Now you can get really fancy too, because what you can do is also say, not only use the color control, but also use the value or the saturation to control other aspects of the behavior. Let's say you want to control speed by value. You could just, then you would end up painting either brighter or darker colors in here. You'd have, or saturation, you could run that way as well to control some other aspect. So there's really a lot of combinations you could explore. We'll go ahead and save this file and post it for you. Enjoy, and let's just go ahead and run this one more time here. So we see these guys move up in here, and as they enter those areas, they end up changing direction. So not the most interesting pattern, but you can go ahead and paint some that do some really cool stuff. And all right, enjoy.